Howdy all. Throughout this part we're going to be looking at section C, question 2 onwards. We'll be going through a few different parts of it. This does have some tricky sections, so if you're having a bit of trouble, make sure you follow along. Throughout I encourage you to pause it throughout certain parts so that you can complete that section. Like before, I'm not going to just be giving you the answers flat out. You do need to use some initiative with these questions. Okay, so with this one, what you need is a circle, all right? And it's really important that circle has a radius of 5 centimeters. If you have a printer, make sure you print off a copy. If you don't have a printer, it's a little bit tricky. You will need to try and make a circle of radius 5 centimeters. The way I would do that is draw a dot in the middle of your page, measure out to one side 5 centimeters, say it's to there, measure out here, measure out here, measure out here, maybe this way too. The more you measure out, the better, 5 centimeters. And then what you can do is you can start to connect them up to make a circle. Your circle will be hopefully much, much nicer than that one. All right. Your drawing will be a bit rougher than if it was printed, but it's better than having absolutely nothing. Once you've done that, you need to divide your circle up into 12 sections like what I've done here. Once it's all divided up neatly, make sure you take your time with this, all right? If it's really, really rough, it'll affect your calculations down the track. Cut out your 12 sections in the space provided below on your GAT under these two diagrams. I'm going to make a rectangle that looks like this, all right? So you're going to almost use the slices like a pizza, fit them together so it makes a rectangle like this. All right, that's the first thing that you need to do. So if you haven't done that yet, pause the video now before continuing on. Okay, the next part says label the length and width of your shape. Now that means the rectangle here that you've created. And it means to actually physically measure it and write out the length and width of it. So as an example, if the length was 20 centimeters, write 20 centimeters, all right? So grab a ruler out, make sure you get the length and width of your shape. For mine, I'm just going to write length and width for now. But you'll have the actual exact measurements. Then you can use those two calculations to calculate the approximate area of your shape by doing length times by the width. Do that now if you haven't already, then pause the video. All right. The next part says label where the circumference and radius would be on your shape. Now that means here, all right? So where the circumference would be and the radius. So having a look at this shape here, the original circle, have a look at what parts make up the radius, all right? It's the sides of almost like your pizza slices. They make up the radius. Using that, where does that appear in the shape, all right? Have a go at that. Also have a think about circumference, the distance around this black part, all right? Where in the shape that you've created does the circumference appear? Pause the video now and have a go at labeling where they both appear. All right, so if you've done that, hopefully you've worked out that the radius is these slices here. So each one of these is the length of the radius, which can also be the side length here. So the side length of the shape that you've created is the radius. Along the side here, if we added this whole length here to this whole length here, we would get the full circumference, all right? So these lengths here, which should look a little bit circular, the top on yours, that plus that will equal that whole distance around. So if you look at just one length, that gives you half of the circumference. So I'm going to write that as half C, meaning half circumference. Now, question 6 says the formula for calculating the area of a circle is A equals pi r squared. So that means area equals pi times radius squared. Using the information from your diagram, explain why this rule works. So, looking at our diagram here, we know that the area is this, the width, which you can also write as the radius, times by the length here, which is half the circumference. What we need to do is we need to rewrite this so it looks like that rule that we were given, area equals pi r squared. Now, we have one value of r. If we've got r squared, that means there's going to be a couple of r's. It's going to sort of look like this. Because r times r equals r squared. We need to rewrite this into this form. Now, right now we have the area. We have the radius here. But now we've got this half circumference. So we need to figure out a way of rewriting this so it looks more like this. Now, hopefully you remember that the circumference of a circle is found by pi times its diameter. Use this fact to work out how we can rewrite this equation so that it will look more like this. Pause the video and have a go at that now. Remember to make sure you're writing all your working out and explaining why the rule works. Alright, so if you've done that, so half the circumference. We know that the circumference can be found as pi times diameter. Now remember, we want half the circumference. So if we were to rewrite this, it would look like this because we're dividing it by 2. Now if we're dividing the diameter by 2, that's the exact same as the radius, because remember the radius is just half of the diameter. So again, we can rewrite this. Instead of saying the diameter divided by 2, we can just write pi times radius. Now if we were to use that information and put it back up into here, this is what it would look like. The area is equal to the radius times by pi times by the radius. Now we can condense this a little bit and simplify. Instead of having r times r, that's the same as saying r squared. So we're left with pi times r squared, which gives us our formula for the area of the circle. Hopefully you were able to work that out yourself and you didn't need too much assistance from the video. Question 7 says, using the formula a equals pi r squared, what we just came up with, find the exact area of the original circle. So use that formula to find out the exact area of a radius 5 centimeter circle, and then discuss how reliable estimation 1 and estimation 2 were and which one was more accurate. So estimation 1 was where you counted the squares within the circle. Estimation 2 was the one where we used this. Have a discussion about what you got for each one, how close you were, how far away you were, and then state the exact area of the original circle.